11.3, conditional probability and events involving and. So conditional probability, its definition is the probability of event B computed on the assumption that event A has happened is called the conditional probability of B given A and is denoted by the following. So this says, what is the probability of B given that A has happened? And we can do an example of this. So from a sample space, S is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're going to be given some questions. So A is going to be the selected number is odd, and B is the number is a multiple of 3. For the first part, let's figure out the probability of B. The number is a multiple of 3. And for the multiples of 3, we're going to be having sample space of 3, 6, 9. Let's get the probability. Our favorable outcomes are going to be 3 things, 3, 6, 9, out of total 10, which is going to be our probability for B. Next up, you want to check the probability of A and B. A states that the selected number is odd. And we can take a look at the set of A, which is going to be 1, 3, 5, 7, 9. So the probability of A and B would be 3 and 9. Because there's only 2 elements that satisfy both these sets. So the probability of A and B is going to be 2 over 10. Now, what if we wanted to look at the probability of B given that A has already happened? Well, how do we do that? The formula for it is going to be the probability of B and A over probability of A. And we already know from our previous encounters that the probability of B and A is going to be 2 over 10. And the probability of A, which is the selected number of odd, is going to be 1, 2, 3, 4, 5 out of 10. And so when we work this out, it'll be 2 over 10 times 10 over 5, going to be 20 over 50. And when we reduce that, we will get 2 over 5. So this is a formula that we need to remember. The probability of B given A will be A intersect B over probability of A, which is also just P and A and B over P of A. Let's do another example. Given a family with 2 children, find the probability of each event. The first one is both are girls, given that at least one is a girl. And so we define the sample space as follows. So we could have a girl, 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 boy, boy, girl, or a boy, boy. And in this case, we could have this represent A, this represent B. So A is both are girls. What's the probability of that? It's 1 over 4. What is the probability that at least one is a girl? That is going to be 1, 2, 3 cases. So 3 of 4. Now we're being told, what is the probability that both are girls given that at least one is a girl? From our formula, we can see that P of A and B over P of B. So I just want you guys to remember that the given part will be on the bottom to reduce the sample size. Even though I might have switched A and B from above formula, it's the same thing when you look at it, that this part of the formula will always be in the bottom. So now let's work it out. What is the probability of A and B? What is A? Both are girls. What is B? At least one is a girl. Well, there's only one case where both are girls. So that is going to be 1 over 4. What is the probability of B? 3 over 4. And then when we work it out, it's going to be 1 over 4 times 4 over 3, which is going to be 4 over 12, which is simply 1/3. So that's our answer for that. Let's do another condition on this. Both are girls, given that the older child is a girl. So from the first example, we had given that at least one is a girl. And the second one, we have that the older one is a girl. And so when we're looking at the probability of each, we can label them. The probability of A, that both are girls, similar to above, is 1 over 4. Probability of B, that the older is a girl, well, we look at the sample space. This girl was born first, so she's older. This one was born first, so she's older. And in these cases, well, for this case, both are boys, but in this case, the boy was born first. So there's only 2 cases in which the older is a girl. So that will be 2 out of 4. Now let's do the conditional probability formula for this. So P of A given B is as follows. Probability of A and B, and then probability of this goes in the bottom, probability of B. And in how many cases can both be girls, given that the older is a girl? How many of them overlap? Only one case. So 1 over 4 over probability of B, which is 2 over 4. Then when we work it out, it's going to be 1 over 4 times 4 over 2. In this case, it's going to be simplified down to 1/2. Now, what happens if they're both independent? Both events are independent. In the case of independent events, the following will apply. If both events are independent, then P of B of A is just going to be equal to P of B, or P of A given B, it's going to be just P of A.